Hello, my name is Sungwon and I'd like to introduce our paper titled Geospatial Referring Image Segmentation with Global Local Context Features. Referring image segmentation aims to find the segmentation mask described by the text. In this example, the green mask is the output of the given input text and image. But the problem is that labeling this dataset is costly. To handle this issue, we propose a new task of social referring image segmentation by leveraging pre-trained clip without any additional training. To find the target object, local and global contexts are important. In this paper, we propose global local context features that capture jointly the target object and the surrounding context. This is our overall framework. Our methods are performed several baselines on this benchmark dataset, and also are performed supervised SOTA methods on unseen domain. Now let's dive into the details. Referring image segmentation aims to find a segmentation mask given a referring expression describing the target object. We show three examples. In this case, the green mask is the correct mask, considering the input text and image. If the text is the button cat, the red mask is correct. The text is given by a scooter with the cat sitting on. The blue mask is the output mask. This task is challenging because it requires a high-level understanding of the language and image, respectively, and prediction of each dense instance level mask. In addition, only one target object must be selected from several objects of the same class. So far, this task has been focused on a fully supervised approach. However, labeling this dataset is costly because it requires the collection of the precise referring expression of the target object as well as its dense mask annotation. To handle this issue, in this paper, we propose a new task of zero-shot referring image segmentation by leveraging pre-trained clip without any additional training. Our zero-shot list framework is motivated from global local context, which consider local and global contexts in the list task. To find the target object, global and local contexts are important. Local context focus on the target class to be selected. Global context consider the relations between objects. We design our framework to extract global local context features on both visual and textual modalities. Our main contributions are summarized as follows. First, we propose a new task of zero-shot referring image segmentation based on clip without any additional training. Second, we present a visual encoder and textual encoder that integrate global and local contexts of images and sentences, respectively. Although the modalities of two encoders are different, our visual and textual features are dealt in a consistent way. Third, the proposed global local context features capture the target object semantics as well as the relations between the objects on both visual and textual modalities. This is our overall framework named Global Local Clip for the zero list task. Our framework mainly consists of two parts: Global Local Visual Encoder for visual representation, and Global Local Textual Encoder for textual representation. Now let's explain how our Global Local Clip works. We generate the mask proposals using the off-the-shelf mask generator, which is the unsupervised instance segmentation model. And we extract global context visual features for each mask proposal, using our proposed mask guide global context visual encoder, which is a modification of the original clip visual encoder. These global context visual features can comprehensively represent the masked area as well as the surrounding region. To obtain local context visual features given a mask proposal, we first mask and crop the image to obtain a new image surrounding only an area of the mask proposal. It is then passed to the visual encoder of clip. Our local context visual features focus only on the specific mask area because cropped images does not contain context information of the image. This plays a key role in this task because we need to focus on a small specific target region to find the target object in the image. We aggregate global and local context features to make a global local context feature for each mask proposal. We extract global sentence feature for our input text by forwarding it into the pre-trained clip text encoder. This feature encodes a comprehensive understanding of the language, but it is hard to focus on the target node indicating the target object described by the expression. To address this problem, we extract a target node phrase from the expression using our target node phrase extraction module using a dependency parsing, and we pass the target node phrase into the clip text encoder to get a local node phrase feature. We fuse global sentence and local node phrase textual feature. Finally, we obtain the score for each mask proposal by computing cosine similarity between global local context visual features and the global local textual feature. And we choose the mask with the highest score. Our methods outperformed several baselines on this benchmark dataset, and also outperformed supervised SOTA methods on unseen domain. Using both global local context features in the visual and textual modalities leads to best performance. This collective result shows our global local context visual feature is effective in this task. To show this effect more clearly, we use Costco instance GT masks as the mask proposals. Using only local context visual feature predict target class but not target object. Global context visual feature capture the context of the expression but find a different object class. Global local context find the target object by considering local and global context. And the same trend holds in the textual modality. Our global local clip identifies the target object better than other baselines. In this case, we use FreeSolo as the mask proposal in all baselines. Thanks for watching our video.